going to try to see if it's streaming. I'm gonna start by doing the Italian thing today, and then I'm gonna structure the classes and prototypes videos. I was able to finish the 2 previous videos yesterday, but they weren't very good, but I was able to get it done. And I had to I spent a bunch of hours editing the first video because I had to do a strategy where I do multiple layers of editing because of the software. So I edited just a small part, then I saved the video into a new one. Then I used the new video to edit the other parts, and I did like this in layers, and had to do 6 different layers. So it took a lot of time just to add some animations. Not animations, but the arrows and the pictures that I was doing. If I put too many things on the same scene, then DaVinci Resolve crashes and I have to reopen again. And I've been watching some videos today about classes, about prototypes in JavaScript. I think this video is gonna be kind of hard to make. But not really, actually. After watching some of the videos, I think my confusion is cleared. It's more annoying to make because it's kind of hard to explain. And I think I'm gonna have to do a video about the under methods as well after classes, because classes, in order to explain what a class is in Python, I'm gonna use the init function because I'm gonna say that it's analogous to the constructor in JavaScript. And before that, I'm gonna explain how the constructor in JavaScript works through the prototypes. So if I do that, then I have to explain the under methods in Python. So I think I'm gonna do the under methods after classes, and then I do decorators. It's probably the best. Trying to think if I can fit this structuring with other video, if it makes sense. Maybe I can put this here as well with the box scope of the Latin var. Yeah, I think I'm gonna do that. Because that way there's less videos to make. And like I said before, I want to finish all these videos before I start doing the blog, because otherwise it's gonna be too much work. So hopefully I can do more than this video today, and then hopefully 3. And in order to do the outline of this video, I'm gonna watch all the videos that I opened here about prototypes, and then I'm gonna use ChatGPT to do the rest, and then I'm going to look for pictures. But I think I'm gonna end up spending less than 1.5 hours because it's not gonna take me that much time. And I don't think I think it's better to just structure one video and then go and film it and then think about the other one. Otherwise, I think it gets confusing. So maybe I'll stream 2 times today if I'm able to get to film everything fast for the other one.
Fa,
Fa,
Does.
fisso,
fisso,
Set. Unchanging.
3,
3,
3.
desiderare,
desiderare,
Desire.
aria,
aria,
Air.
bene,
bene,
Well.
anche,
anche,
Also.
giocare,
giocare,
Play.
piccolo,
piccolo,
Small.
fine,
fine,
End.
mettere,
mettere,
put,
casa,
casa, home,
home,
leggere,
leggere,
read,
read,
mano,
mano,
hand,
portare,
portare,
carry,
grande,
grande,
large,
compitare,
compitare,
spell, words,
aggiungere,
aggiungere,
add,
anche,
anche,
even, also,
terra,
terra,
land,
qui,
qui,
here,
devo,
devo,
I must,
grande,
grande,
big,
alto,
alto,
high, tall,
tale,
tale,
such,
seguire,
seguire,
follow,
atto,
atto,
enact,
perché,
perché,
why,
chiedere,
chiedere,
ask,
maschi,
maschi,
men,
cambiamento,
cambiamento,
a change,
è andato,
è andato,
he, she went,
luce,
luci,
light,
tipo,
tipo,
kind, of thing,
spento,
spento,
turned off,
bisogno,
bisogno,
need,
casa,
casa,
house,
immagine,
immagine,
image,
provare,
provare,
try,
noi,
noi,
us,
di nuovo,
di nuovo,
again,
animale,
animale,
animal,
punto,
punto,
point,
madre,
madre,
mother,
mondo,
mondo,
world,
vicino,
vicino,
near,
costruire,
costruire,
build,
se stesso,
se stesso,
himself,
terra,
terra,
earth,
padre,
padre.
father,
Yeah, as far as I understand right now from the videos that I watched, prototype is a property that every function has that points to an object. And the way that a class works in JavaScript is you have an object and then each key of the object has a function. And that's how you, in order to instantiate the object, you use the object constructor, which is this prototype activates. This prototype calls the object constructor and then also does something else that I already forgot. And then through that you have the same mechanism of a class. And in JavaScript you can also use the new keywords to instantiate classes, but in Python you don't. In Python you just put the name of the class, I think. Yeah. And I was gonna say something else, but I forgot. Oh yeah, the way that I like thinking about classes is that they are a marriage between functions and objects. So if a function and an object had a baby, it would be a class, because that's all a class is an object that has functions. And the constructor allows you to build instances of the class. The other thing that I'm thinking about saying is an analogy with some sort of template, but I still haven't thought about which kind of template would be good to do. Most people do it with animals, and I think that's a good one. But I was thinking about making the analogy with a human being. Like you have the template, which is the construction, the abstraction of what a human being is or a species is, and then through that classification, you have billions of potential different things that can be considered as the same thing. So if you say a human being, most people are gonna assume that you're talking about something that has a heart and a brain, for example, and a stomach. So those are the fundamental structures of what a human being is, and that would be considered as the class, which is the template from which each instance of the class gets created. And then each instance of the class can be different because you can have different attributes, and yeah, that's pretty much the differences between different attributes and different properties on when initializing. There's also this distinction that I have to search for that I'm not sure about it myself really well. The difference between an attribute and the, I don't know how to say that, but the thing that is on the constructor, the self that, well, I think I know the difference. So the difference is that the attribute is common between all the classes, but the attributes that are inside of the constructor are different. So if you want something that all the classes have, you put outside of the constructor, you make that an attribute, and then all the classes are gonna share that thing, I think. But I have to search for this, so I'm gonna ask ChatGPT, I think. Attributes outside of constructor and the attributes outside constructor. Maybe I should explain the under methods before I do classes, just so that I don't have to say that I'm gonna explain later what a dunder method is. I think I'm gonna roll on the RNG and see what happens. So I'm gonna roll three times. 15 last is 50. 0 to 50 is gonna be the under methods first, and then 50 up is classes. Yeah, the under methods it is 42. So I'm gonna change there. I'm still gonna watch all these videos about classes, but then I'm gonna study the under methods first. Maybe I can do the outline of both of them now, and then I'll do the videos one after the other. I hope the under methods is not that hard to do. Because I don't think there's much to explain about it. I'm not really sure. And when I studied, maybe I'll study, I think for this, it's probably better to use ChatGPT along with the documentation. So, yeah. Because Python documentation is really good. I remember reading a bunch of the parts of the documentation. But it is hard to find the things. So I think the combination of the ChatGPT and the library is really good. I'll change this thing here. I think the ones that I have done, but I didn't want to mark this as done as the red color because I haven't posted. So maybe if I lose the videos and stuff like that, then it's not marked. But I think I'm gonna put in blue the ones that I have made it and edited, and then after I post, I put it in red. So now I'm gonna open this again here. Oh, the thing is that Python, JavaScript doesn't have the under methods, so under methods. I don't, maybe I can search for this as well because I don't know. Maybe there is something that is similar to the under methods in JavaScript and I just don't know. But I don't think I ever saw that. I know that decorators exist in JavaScript, but the name is different. But then their methods I never seen, I think. Yes, let me continue to watch these videos and then I'll go study with ChatGPT.
And we're going to call waffle.eat. And call that. Wait, the waffle, we're back where we started, but let's get that carrot into place too. Using const here, const means that you cannot change the variable later. Otherwise, it's just.
Well, let me create the video outline first. I'm gonna close this one and then create the other.
Let, you should always use const if you don't explicitly need the mutability of let, or for that matter. You should use for assuming some old environment or something. Anyway, carrot dot note, carrot and carrot dot eat. You all know what this will return. You ate the waffle, you ate the carrot. Looking at this example, you might infer that object.create creates a copy of the object. Let's see if that is true. Going to move this up a bit, and I'm going to do this. Food dot eat plus function console.log. You totally ate the this dot uppercase. One, two uppercase, right? And we're on it. What do you think will happen? I will suck and not being able to code. Right, try again. You totally ate apple and you totally ate carrot. But this is kind of strange. This means that object.create cannot possibly be creating copies, because if it did, this food.eat would not be affecting the eat methods of waffles and carrots, because they should be copies, right? But they do. Since you totally ate the waffle, the new method signature does affect the waffle and carrots, even though we assign it to the food object. This is, of course, because the object of create does not create a copy of the food object. Instead, what it does is that it creates a new empty object for waffle and carrot, and it assigns food to be a sort of fallback for those. So whenever we call a method or a property on a carrot or a waffle that doesn't exist on the carrot and waffle, it will look in its prototype object, the food object, and see if it's there, and then if it is, it will use that one. And that's what we mean by waffle and carrot having food as its prototype. So object.create creates a new object and assigns food as its prototype. But waffle and carrot will only fall back to food if it lacks the property. If it has the property, it will use that. Let me show you what that means. I am going to delete all the carrot stuff from here. Carrot, delete, and we no longer need this example. But I am going to
It's
add
kind of like it's inheriting everything from food. And then if there is a function already, then it overrides the initial one. But if it doesn't, then it goes to the beginning, to the source one, the parents.
another eat method. I'm going to clear this, and now we're going to run it just to see what it looks as. You ate waffle, you ate waffle, you ate waffle, you ate. Now let's see what if I do this. Food dot type. What will he type? He will type. When I run, what do you think will happen? I will give you a golden star if you figure this out before I run it. What do you think? 3, 2, 1. You knew that one, right? But what if I comment out the init? Let's check it. No, not prototypes. But yes, did you guess correctly? You guessed. You ate the undefined. You ate. So in this first eat call here, waffle will not have a anything assigned to the type property, and when it looks in its prototype, the food object, it will not have anything there either. So it's going to return undefined. However, here we assign the string to the type property on the food object, which means that when in this second call here, waffle.eat will, well, it still won't find any type property on itself because, well, that's assigned here in the init function, and the init function is commented out, but it will fall back to its food prototype, and there it will find food.type stuff, and I'll put it here. I also quickly want to mention that you can use prototypes to do type checking. I'm going to delete this part here and bring back the carrot and waffles that we saw before. And now you can actually do food.isPrototype of waffle. You can do food is prototype of 1, 2, 3, 4, 5, something bigger, and food is prototype of carrot. Is food. Waffle is food. Oh, this is super exciting entertainment. And right, we're gonna do int is food. Do you know what this is gonna be? I think you do, right? I think you're anticipating this. I'm running it. Node.prototypes.js, and waffle is food true, int is food false, and just true, yeah. Carrot is food. No, what? Okay. No, carrot is food, clear. Clear! Oh my god, I'm so tired. Right, carrot. Carrot is food true. So you see that you can use the food prototype to see if that is used as a prototype in different objects, and that is an excellent way of doing type checking. And that is the basics of prototypes. There really isn't much more to prototypes than that. However, while the concept of the prototype is simple, it does have some very cool implications for the language. So on the next episode, we're going to explore that a bit. We're going to explore why prototypes are more powerful than classes, and I'm going to show you some cool tricks that you can do with it. Do not miss that episode. As usual, it will be released next Monday morning, 0800 GMT. But if you want more videos like this one right now, you should check out either the composition over inheritance video or the factory functions video. I am MPJ. This is Fun Function. Until next Monday, stay tuned.
All right, today I want to talk about linking prototype objects and how to build a prototype chain. So what a prototype is, how it's connected to objects, how you can get to all these methods that exist inside prototypes that are nested way deep in the prototype chain. Okay, now we have here a function called otherPro. This function is going to be used as a constructor function. So it's a function that will build other objects. Inside of the function, you can see we're using the keyword this here. And that's a good sign that this is a constructor function. Whenever we use the keyword this, we're talking about the instance. So we call new.
Not sure if I should mention composition versus object-oriented programming on the video about classes. Maybe I should just briefly, I think I'm gonna briefly mention because I think it's important, but then I'm not gonna explain it because it's too hard and too deep of a topic, I think. And I'm myself gonna have to study a lot more to understand. I think I don't understand the main fundamental differences by the principle, which is the composition is the stuff that I was talking about the feminine and the masculine for JavaScript and Python, the distinction. Composition is more feminine and object-oriented is more masculine. So it's more rigid and has more structure, but composition has more flexibility and potential. So that's why I think that JavaScript favors more a composition approach and Python favors more an object-oriented approach. But I'm not really sure if that's the case. I would have to study a lot more to understand that. So it was a video that I was thinking about doing in the future, but I'm not really sure if I'm gonna do it or not because there's so many video ideas and things to do. I think the direction that I wanna go more is the thing that after I finish these videos, I'm not sure which path I'm gonna follow, but I'm between the path of data structures and algorithms because it's something that I have to become stronger at. I have to study more. And since I haven't done any interviews for jobs, I'm not sure how it's gonna be, what kind of questions they're gonna ask, because I'm gonna go for jobs in companies that are not FANG. I think I'm gonna go for jobs that are in startups first, or smaller companies. And I've heard that for those kinds of companies, they test more for practical things instead of asking for algorithms. So I'm not really sure how relevant that's gonna be. So this is the thing that is weighing me towards making videos about data structures and algorithms because then I get to study them. And as I study them, then I can make the videos with the stuff that I study. So pretty much I do what I talked about that I was gonna do in this stream, which is to study all of this stuff, and then I compress the information that I spend a bunch of hours studying into a fraction, maybe 10 minutes or something like that. And by doing that, I gain a much better understanding of the topic, and I also am able to produce the videos for the other channel. So that's the direction that's the thing that is making me take that into consideration. But then the path that I really want to go is with blockchain. I want to study all the consensus protocols and then make videos about them and think about the trade-offs. And eventually, I want to be at the intersection of blockchain and AI because I think it's the future. And I remember seeing a video or a live stream from Theo, and that wasn't that long ago actually. And then he explains really well how the YouTube algorithm works, and I think it makes a lot of sense the way that he explained it. Because if you're thinking about it, it's just a machine learning model. So what that means is that it probably needs a lot of data in order to fit your video style with the audience. I imagine what's happening on YouTube and Facebook and all these other companies is that they have archetypes of personality structures. Like the Jungian archetype, for example, the hero's journey is an archetype which is a story that is passed over the generations that stays on the collective consciousness. So it's kind of like an identity of a culture or the collective consciousness. And what these algorithms are doing is they're using all the data from the impulses and the behavior of human beings on the site in order to create these archetypes of people, which are the avatars of consumers in business. And I think that they train the machine learning models based on these archetypes. But the way that they're doing is because they're maximizing. That's the thing that I'm not sure, because they're maximizing to profit. And I myself, and I think that's a very common thing that many people experience, you get into these loopholes where the algorithm doesn't necessarily recommend the videos that are best for you. It just recommends based on what you watch, what you click most of the time, and then it ends up putting you in an echo chamber. So I think the algorithms are not in the phase yet where they are very good and nuanced. But that's the thing, they might be, but they might be just optimizing for profit, and that leads to the echo chambers, because they might have realized that that is not optimal the way that they are doing for recommending videos, but it is optimal for increasing profit, and that leads to the echo chambers. But either way, I think that this is the algorithm in the way that it is right now, which is it leads you to echo chambers, and then the videos, that's how the machine learning model works. It starts recommending the videos for these people that are in these echo chambers. And if you're trying to make a YouTube channel and you make videos about too many different topics, then the algorithm can't train itself in order to put you in an echo chamber. So this is the kind of a challenge I have, because obviously I don't want to be in one single echo chamber. There's a lot of things that I want to study, but then if I make videos about all of these different things, I'm concerned that over the time of the channel, it's either gonna be too dispersed, and the YouTube algorithm is not gonna be able to find the right audience to recommend the videos, or yeah, or I'm gonna be too fixed on too compromised on a single topic, and then I'm not gonna be able to make videos about anything else. So the way that I started, I'm doing these videos about Python and JavaScript, and I don't want to be on the box of just Python and JavaScript and teaching these things, because the way that I was thinking in the beginning, I wasn't thinking like the YouTube algorithm. I was just thinking about how can I add a lot of value to the people that are going to watch my videos, which are the people that I would consider myself to be when I was starting. So I don't want to study just one thing. I wanted to understand everything, like multiple different languages, and then the frameworks and the whole landscape of the industry. But based on this thing that Tao talks about, it made me think, and I think it makes a lot of sense. So it's kind of hard to find the middle ground there of what kind of videos to make, and yeah, which direction to go, if I just make videos about one topic or if I make videos about a bunch of different topics. But I think that this way is a good compromise between the two, where I start off like this and then I go more into the blockchain stuff, and then from the blockchain later on in the future, once I have a lot of more knowledge of both on programming and the blockchain, then I can start making videos about AI as well. And that intersection, I think, is the best to be at, I think. But then that means that I can't really, or it wouldn't be a very good idea to start making videos about things like Django or Next.js or React or data structures and algorithms, because it doesn't make sense with the overall vision that I have of the evolution of this place of where I want to be and where I think the videos are going to be. It's going to be better to train the algorithm to, which is going to be the intersection of blockchain and AI. So I'm still not 100% sure which direction I'm going to go.
and then the function name. When you do that, it runs this constructor function and it builds an object for you. I don't have to put the keyword return here. It automatically returns the instance of the object. Now, after we have this function defined, we can, on that function, say its prototype is going to get some method. So we are adding a method into the prototype object. The function is the constructor. A constructor function automatically gets a prototype object, and we're creating some method inside of that object. So you can think of it like this. We have down here, this is our instance object. We're calling new proto. So there's an object inside of ob. It will have as its prototype other proto. Now, other proto is in itself an object. This function is an object. In JavaScript, functions aren't special things. Well, they are special things, but they are considered to be just another object. So when you create a function, what you're really doing behind the scenes is calling new object, and then it's an object of type function. So this is going to be going up to the object prototype. And then that points to null. So as you go all the way up the prototype chain, the very top of it is always null. Now object, this is the one that we get when we call new object. This is the function that we're running. Other proto is a function that we're running. So it has a prototype, and its prototype points to object prototype. And then we have our instance, which is using other proto as a constructor function, as its prototype. So we've got, this is the chain that we're working with here. Object points to other prototype, which points to object prototype, which points to null. So when we call this, when we say new is equal to other proto, we have created an object, and this object has everything that's attached to this. So we can say obj.prop1. That's going to exist there, that's not a problem. We can console log that out if we want. That will give us the 456, and that property exists inside of obj. So directly inside here, inside that. This method here, inner, also is being placed inside of here because we put this in front of it. So we can call obj.inner, and that's going to work. That's going to write this inner method. So let's open up our console here and we'll run that just to see those things. There's the 456. Let's scroll this up. There's the 456, and then inner. Okay, great. Now, some method exists inside the other prototype, inside this part right here. That's where
Based on this stuff as well, it makes me think that prototypes are just tree structures. It's the same thing. I don't really see the difference between the two. Because a tree is just a nested hierarchy of objects as well. So I think it's pretty much the same thing. Maybe it isn't, but from my understanding now, I think it's pretty much the same.
Method exists. But because it's on the prototype chain, I'm allowed to use it. I can call some method like that. This is other proto. That's the message that we have right here. Okay, great. So we've got this instance, which has its own property1 and inner method. You can also use the things that are on the prototype chain. And object prototype has things like toString. And that's why we can do this, toString. That's going to work. We're not going to get an error there. No errors, because the toString method exists on this prototype chain. Inside of object prototype, there's a toString method. That's why we can do that. Now, this one here, inner, because we put this in front of it, it means that the inner method exists inside of obj. That's why we do this. But it doesn't exist inside of other proto, even though we wrote it here. Because of this, it exists inside of obj. If I try to do obj dot and then get its prototype, so we can do underscore proto, that will get me the prototype of this object, and try to call some method. That's going to crash. That is not going to work. Oh, sorry. Of course it's going to work. We've got that there. Inner, this is the one I was trying to use. You probably got that one before I did. There's the one crashing. So inner is not on the prototype chain. Inner only exists inside of obj. Now this double underscore proto, this is a special property, and I put it up in the comments here. Proto belongs to any object, so an instance of an object, of any kind of object. There is a proto property. This is what points to here, this prototype guy. The other way of getting it is object get prototype of, and then you put in this, or set prototype of if you wanted to change it. So I'm going to do it this way, just to show you the alternate syntax.
Oh, actually, proto is a dinner method. If you think about it. So maybe this is a good question to ask. Is proto JavaScript same as Python? I think first I'm gonna ask what are the differences, and then I ask this next.
So the same way of doing this is this. So object is placed inside of here, object get prototype of. So I'm talking about the prototype of this function right here. So this is the object that we're talking about. And here, if I try to call inner, that will fail. But I can do some method. That will work. That will fail. Just like this fails. Okay, so let's comment those out. I'm going to show you another way of doing this. Just comment all those. There we go. All right, moving on to part number 2, the alternate way of doing this. Instead of doing this, a constructor function, which is going to create your object and then create this prototype, I want to talk about what happens if you just do this. If I say let, I'm going to create something called proto object. If I say that's going to be an object, and inside of it there's going to be a prop1, we'll say it's 456. Just like that, we can add inside of here some method. Okay, now this in itself looks like an object instance, and it is. Proto is an object, it's an instance of an object. So how do we get this? Well, doing this was the exact same thing as saying new object, and then getting the properties. So if I said let proto object equal new object, and then proto object dot prop1 equals 456, proto object dot some method equals function, and so on, just like that. This new object, this is the actual syntax. This is our constructor. Do you remember back up here? Let me clear that out and close the console for a moment. So scroll this up. Right here, we call new to create it. That's the constructor function. This is the thing that creates the object instance and creates the prototype. And down here, we're doing the same thing. We're calling a constructor function to build our object, and it creates the prototype. So if we wanted to, we could do proto object dot prototype dot other method equals function, just like this, just like we do with the some method up above. Right, so we have a prototype on proto object, but this syntax isn't going to work because this is an instance. It's not a function, so we can't do this prototype. What we need to do to get to the prototype of an instance is what we did right here, the underscore proto. So we could do that, or alternatively, we can say object dot get prototype of, and then you put in prototype proto object. Then you can say dot other method. Like that. Okay. So we do have a prototype here. When I do this, what I'm really doing is I'm saying, here's the instance, and the prototype of this is the object prototype. So I'm adding this onto the object prototype for this guy. Now, if I want to use this as a prototype to kind of stick it in the middle, we can do something similar to what we did above. We can say, let's declare a child object. Just keep it empty for the moment. Just keep it simple. And then what I want to build here is I want to say that child object is going to point to proto object as its prototype, which is in turn going to point to the object prototype, which points to, as always, no. So I want to use, if I have a child object instance, I want to use proto object as its prototype. Because this was an instance, I had to use this property to get to its prototype. But I want to use that itself as my prototype here. So we can say object dot set prototype of child object, and we're going to use proto object as the prototype. So we are inserting this right here up above child, and that way child object now has access to everything inside here. We can say child object dot prop1. Let's log that out. We can do child object dot some method. We can do child object dot other method. And what happens is we go up this prototype chain looking for other method, which is sitting up here. We're looking for some method, which is sitting right here. So we're here, and we have this prototype chain that's built. We can crawl up the chain and use that. There we go. 4, 5, 6. That was prop 1. This, you can see there's nothing inside of child object, but inside prototype object, that is what we just set as our prototype right here. We have access to the 4, 5, 6 and the some method and the other method. So because they're on our prototype chain, sitting somewhere along this chain, we have access to all these things, even though they're not defined specifically in here. Unlike a class-based object, where when you are creating a class and you're saying it extends to some other class, what happens then is you copy everything down. So child object would actually have copies of everything. If this were a class-based language, you have copies of everything that's inside prototype object, object prototype. But we don't. We're prototype, which means there's links created. We have this chain that we built, and JavaScript is allowed to crawl up this chain, looking to see, hey, do you have this property? Do you have this method? Do you have this property? Do you have this method? And it's not until it gets to this point where it says, okay, this is the end of the line. I could not find that property. So if I said child object dot non-method, which doesn't exist anywhere in this prototype chain, that's when I get an error. There we go. Child object non-method is not a function because it does not exist anywhere along this chain. Okay, now there's a newer syntax for doing what we just did here. Remember, this object set prototype. There's an alternate way of doing that, and that is with the object create method. So if I create a child object 2, I can say object.create, and I'm going to use proto object as my prototype. So effectively, I've done these two lines together in a single line. That's what we're doing here. We're creating a blank object. I haven't defined any additional properties, so this is a blank object, and this is set as a prototype. Just those two lines combined. That's what we're doing right here. So we do have child object 2, which is pointing to proto object as a prototype, which in turn is pointing to object.prototype, which finally gets up to null. So that's our big long chain that we've got. And as always, we can access from child object 2 anything that is inside the chain, which means this prop 1 up inside the prototype object. We can access that. I'm just going to comment these out so we stop getting errors or anything. Right, there's the 4, 5, 6. So this is coming from proto object. Now, the interesting thing about properties is, if I now do this, if I do child object 2 dot prop 1, because this told me 4, 5, 6, so it looks like I have a property called prop 1 inside of child object. But if I try and change the value, let's say 777, and I console.log, and with an C there, child object 2 dot prop 1. If I write that out, I'm going to get the 777, so I will get what you would expect. There's the 777. So what we've done here is we've actually created a new property inside child object 2 called prop 1. We have not done anything to the original prop 1. Come back up here, prop 1 inside of proto object. We haven't touched that at all. So this is where prop 1 was. When we console logged that out, we were getting the value from here. By doing this, we're adding a property to here. So if I do this, and I also say, but what is the value inside my prototype, we'll be able to see both values coming up here. And you can see 777, that's the brand new one that's inside of child object 2, but there's still one up inside the proto object, which is 4, 5, 6. And the same idea applies to methods as well. You've got methods that can exist inside of here, or inside of here, or inside of here. Down at this level, if you just write the name of the method, JavaScript is going to go up the chain looking for that. When you add methods or change methods, what you're doing is you have to point out which one do you want to change. So inside of proto object, we have something called some method up here. I can add a brand new one down inside of child object 2. So child object 2, some method, calls the one inside proto object. But if I do child object 2 dot some
I
method,
think a good thing to do to explain this, because the way that he's explaining here, it is good, but I got confused because of the arrows here. Initially, I was thinking about, instead of thinking about this as the layer on the surface, and then this one, the layer on the bottom, I was thinking in the other way around because of the direction of the arrow. So this was kind of confusing to me. So I think a good thing to do to explain this is to take a picture of a tree, and then to create some snippets of code in the way that he's doing here, where I show this chain of prototypes, and then I put this one in the root, the null in the root, and the other one in the leaf, the one in the surface. And that's gonna make it easier to understand, I think.
if I type it, equals function. We are actually creating a brand new some method sitting right here. This is where the method sits that we're going to call. If I do child object 2 some method. But if I go child object 2 dot proto some method, then I'm going up that chain. I'm actually crawling up the prototype chain. And you can see the last two lines here. This is the one that's inside of child object 2. This is the one that's up the prototype
Maybe
chain.
I can make an analogy with photosynthesis, but I don't remember really well how it works. I know there's some weird stuff that happens with trees that for the water to go up is something that has to do with the connection of hydrogen and oxygen that makes the water go up, because there's something there that I forgot about it. So if I'm gonna do the analogy, then I would have to think about that as well. So I'm not really sure if I'm gonna do it or not. But I think it would be a good analogy with photosynthesis, where in order for the tree to get the nutrients, it uses the sunlight and then it goes all the way to the root. But I'm not sure if it's a good analogy, because it would be a good analogy if in order to maximize the efficiency of the, maybe solar panels can be a good analogy. In order to maximize the efficiency of the conversion of energy, if the surface layer doesn't have enough nutrients to get the light, then it has to go layers deep until it gets to the root of the system in order to extract the most amount of energy. And it's the same thing with the prototype chains, where if you don't have this stuff on one object, then it's gonna go all the way to the root until trying to find the stuff that you need until it gets to the root, and then if it doesn't exist, then it returns an error.
But if this one didn't exist, what we're going to do is JavaScript will crawl up the chain looking to see if it can find it until it gets to the very end to this null. And if it hasn't found it by that point, that's when it gives up.
But I think using the tree is a good analogy, because then it makes the subconscious connection for the person of the later on, once they study tree structures, that they're going to remember that, and it's going to make an analogy in their brain to see that is analogous one to the other, the data structures.
That's an error. All right, so copy of this code is available down in the description as a link to a code gist. If you have any questions, please feel free to put those in the comments down below. I hope this helps you understand the prototype chain a little bit better and where things get placed and what's going on. Just remember, when you're using a function as a constructor, you're getting a prototype created for you. If you were just using this syntax, then the object prototype is what you're getting at the very beginning. It's like you're calling a new object. You still get a prototype, but it's the object prototype that you're getting. And use the methods get prototype of, set prototype of to get or change the prototype, or the new syntax, which is right here, object create. That's probably the simplest and easiest way to do it. It's a great new method. All right, as always, thanks for watching.
I think that those are all the videos. Maybe I'll watch some more videos about the under methods. And I think I'm gonna have to study more. I'm gonna have to watch more videos on prototypes. Maybe study with ChatGPT and the documentation to understand a little bit more in order to make the video. I think I understand now how it works, but it's still a little bit confusing in my mind. I'm trying to think about good ways to explain that are gonna make it easier without having to show a bunch of examples, because I think is the difficult thing is not understanding the concept, is understanding the bigger picture of the way that is used in practice. I think that's the hard part to really understand in your mind just with the explanation. So those differences between this proto here and prototype, I didn't understand really well. Like, what is the difference between proto and prototype? And then the whole new object thing I understand, but I'm not really sure if I understand 100%, because it seems like the new object constructor is the thing that constructs all the prototypes. All the prototypes use under the hood the new object thing. But then I'm not really sure, because where does the new keyword come from then? But maybe it is something from the compiler or the interpreter for JavaScript. Not really sure. Python $_ methods are special methods that have names with a $_ prefix and suffix, such as init or len. These methods are used to define the behavior of certain Python language features, such as object instantiation, operator overloading, and attribute access. To define the behavior of certain Python languages features. JavaScript does not have a concept of dunder methods. However, JavaScript does have a number of similar language features that allow you to define special behavior for certain operations. JavaScript can use the constructor method to define the behavior of the new operator when it is used to create an instance of an object. This is another good question, I think, which is, I think this one I'm gonna put on the other stuff because it doesn't fit. What is the difference between new and needs? But the thing is that I wanna think about a way to ask this question that is not gonna give me a superficial answer. I wanna kind of dive deep in the same way that I did in the previous video that I streamed, which I don't remember what was. But I wanna understand the fundamental differences in the design of the language for, like, what are the implicit implications of using dunder methods to construct a class and using the new, if there are any, or if it's just the same thing and just a different syntax. I want to understand that. Maybe I can ask this question. Maybe it's a good question to ask. Implicit implications of the differences between and unique design of Python JavaScript. Something like this. You can also use the get and set method to define behavior for getting and setting the values of an object's properties. Finally, you can use the symbol.iterator method to define the behavior of the for-off loop when it is used to iterate over the elements of an object. These are just a few examples, but there are many other ways in which you can customize the behavior of JavaScript objects and language features. Is a property that is present on every object in JavaScript and is used to access the prototype of the object. In JavaScript, an object's prototype is an object that the object inherits properties and methods from. When you try to access a property or method of an object, JavaScript will first look for the property or method on the object itself. Methods. If it's not found, JavaScript will look for the property or method on the object's prototype. This process continues up to the prototype chain until the property or method is found or the end of the prototype chain is reached. The proto property is a legacy. So this is the kind of thing that I want to understand more, because I get that it follows the prototype chain, and then each object has a prototype. But what are the implications and differences between that and the way that that Python is? Like, what's the difference between this and inheriting a class, for example? Because it would be the same thing. The only difference that I can see now is that in the prototype, the inheritance is implicit. So every object has an inheritance property based on this prototype chain because it comes on the language and is done under the hood. And Python, you have to explicitly tell to inherit one object with the other. So maybe that is a fundamental difference, because that way in Python you have more flexibility to create the classes, but it is still the same thing because you can create different classes as well in JavaScript, and they're both gonna have prototypes, but then they're different prototypes. So it's the same concept, I think. I have to clarify more this difference in order to be able to make the video, I think. The proto property is a legacy property that was used in older versions of JavaScript to access the prototype of an object. It is not recommended to use this property as it is not supported in all JavaScript environments and has been replaced by the object get prototype of method. In Python, the double underscore methods are special methods that have names with a double underscore prefix and suffix, such as init or len. The methods are used to define the behavior of certain Python languages features, such as objects, instantiation, operator overloading, and attribute access. They are not related to the concept of prototypes in JavaScript. Another more advanced concept that I can make a video about is the whole thing of, I think it's polymorphism or something like that. But Python and JavaScript, I think that's very important because it's done under the hood, if I'm not mistaken. But on C++, I remember studying this stuff where you have two languages of different types, because each language you have to initialize it explaining which type is going to be. So integer, float, and string, things like that. And if you have the same language with different types, then you can override them. And that's the concept of polymorphism, I think. But I don't really remember that well. But I don't think it's worth it to make a video about this just for Python and JavaScript. But maybe I should mention this once I'm talking about the nuances of JavaScript and Python. Yeah, I'm not sure. Yeah, so now I can either go with this direction here, or I can go with the direction of asking more questions about the other methods. I still don't understand the difference between the proto. I get that it's a property, and these are methods. Maybe that's the difference. But because a method is a function and a property is a key, I think. So the proto allows you to access the prototype. Just It's a property that it is present on every function in JavaScript, and it is used to define the prototype of objects created by the function when it is used as a constructor. So I think the only difference between when a function is used as a constructor or not is the use of this keyword inside of the function. So this is what I'm gonna ask. What are the criteria to determine required criteria? This call the person function is defined with a prototype property that has a say hello method. This method is then inherited by the person object when it is created using the new operator. This method is then inherited by the person object when it is created using the new operator. So if you don't use the new, you can still call the function, but then you don't get a prototype, I think. The say hello function. The proto property of the person object is used to access the object's prototype, which is the same object as the person.prototype object. It's generally not recommended to use the proto property as it is not supported in all JavaScript environments. It's been replaced by this, whatever. So the new allows you to get access to the prototype. That's what it. And every function, regardless of whether or not it has the this keyword, can be called with the new constructor, and that allows you to have the access to the prototypes of the function. And then every function has a prototype. I think I'm gonna write this down. A function has a prototype when you initialize a function, the new keyword, it gives access to the prototype. The proto property allows you to access prototype. And is equivalent to saying function of prototype. S3. if you try a function from class it follows the prototype until finds its yeah. So the thing that I want to understand is how the object. So this is the question that I'm gonna ask next, which is how is the object constructor created? Here's a more, but I think the answer is gonna be probably that it also has it has one layer deeper until it gets to null, but I'm not really sure. Here's a more detailed example that demonstrates how the new operator works. This example, the person function is used as a constructor because it is called with the new operator. When the new operator is used, the new empty object is created and the person function is called with this set to the new object. The name property is added to the object and then the object is returned as the result of the new operator. The say hello method is added to the prototype of the person function and it is inherited by the person object when it is created. When the say hello method is called on the person object, it logs a message to the console using the name property of the object. I think I'm gonna copy this and put it. I think I closed. No. Yeah. I'll put here. I think I'm gonna use this one. To explain, but I'm not really sure. It's gonna be difficult to find a good way to explain this in a way that is simple and concise. I think the best thing is the tree analogy that I said there. To take pictures of the code and then show a picture of the tree with the code on the leaves going deeper into the root and then explain that this is the prototype chain. And every time you create a function, it has a prototype. It's centered on the root, which is the prototype. So it's like you're growing a leaf or you're growing a flower or something like that. I don't know what's the right word for a small tree is, if there is a word for that. Maybe, yeah, you can say that the prototypes are the roots of every function in JavaScript. And then when you use the new keyword, it creates an access to that for whatever variable you're creating to the prototype of the function. But if you don't use the new keywords, then you are only calling the function. You don't have access to the root of the function anymore. I think that's a good way to explain it. So I think this is answer. There is no difference. There is a difference, but they both do the same thing. But then Proto is deprecated, so you should use the other stuff there. I think Proto actually gives you access to the prototype, so it's not exactly the same thing, but it can be used in the same way, as far as I understand from this. Because it's saying here that they are equal, but then previously it said that Proto points to the prototype, I think. So I'm not really sure. So I think now I have to ask questions about the other methods, because then once I clarify the other methods, then I'm going to be able to make the connections and the differences and similarities between the other methods and this the other methods of the init, which is the constructor in Python, and then the way that the constructor and the prototype chain works in JavaScript. And I have to be careful with these answers from ChatGPT, because I know it's not 100% accurate. And that's why I watch videos as well, to gain more context. But a lot of this stuff I also studied a bunch, so it's not like I don't have any understanding at all. It's just more that, so I think if there's something that it looks suspicious, I'm probably going to be able to catch it, but it's still better to be cautious, I think. So off stream, I'm going to watch more videos about it, I think. And this is one of the reasons why I expected these videos should be harder to make as well. Because it's not that the concepts are really hard, it's just that you have to watch a lot of videos and to be careful with the nuances, so that I don't say anything that's really wrong in the video, which is kind of the annoying part. But it's good because then it forces me to understand this better as well. And this is the gap that I'm trying to fill as well, which is a lot of these videos talk about, they explain what it is, but they don't explain the fundamental differences in the language design, that is the implications that these decisions have under the hood of the way that the language is structured. And this is the stuff that I'm trying to understand better. So, but it's very difficult to explain these things when you're making the video. Yeah, I'm never really sure if I'm doing a good job of explaining that when I make these videos, of getting this point across. Stuff that I have confusion about, that a lot of these videos don't explain really well. But maybe they do explain, it's just that I don't. They're not for me, let's say. They don't explain in a way that is easier for my way of thinking to understand. I think this is fun because different people resonate with different teachers, so you can have different people explaining the same thing, and then one person is going to understand more from the other one than it is from another, and vice versa. Python, the demo underscore methods are special methods that have names with a demo underscore prefix and suffix. Methods are used to define behaviors, blah blah blah. Here's an example of a Python class that defines an init under method to initialize an object when it is created. This example, the init method is called when the person object is created using the person class. The init method is passed the self argument, which is a reference to the object being created. The init method then sets the name property of the object to the value passed as an argument. Python's dunder methods are similar to methods on JavaScript's prototypes in that they allow you to define custom behavior for certain operations. However, there are some key differences between the two. The other methods are specific to Python, while prototypes are a language feature of JavaScript. The other methods are defined directly in the class definition, while prototypes are defined on the constructor function of a class in JavaScript. I don't really understand this. If it does make sense or not. Yeah, I'm not sure if this makes sense, because it seems like it is the same thing. Then their methods have a standard set of names and meanings, while prototypes can have any property name. Oh, that is a difference, because each then their method is specific to the thing that it's gonna do. While prototypes can have any properties name. So I think the question that I have to clarify is what exactly is a class in Python? Like, what does it mean to create a class, and how is it different? Because in Python, a class is a function that points to an object, I think. That's what a class is. So it starts at a function and then points to the object, and the object has more keys that have functions as well. And that's the prototype chain, because each prototype is gonna have keys. Because each prototype is an object, it has keys, and these keys are gonna be equal to a function. The value of the keys are gonna be a function. Then you can have multiple different prototypes in the chain, because that prototype can have another prototype. It's kind of like a linked list because of the structure of pointers. But then what does it mean to create a class in Python? Then the methods are called automatically by the Python interpreter, while prototypes are accessed indirectly through the inheritance chain. Overall, the main difference between dunder methods and prototypes is that dunder methods are a language feature of Python. They're used to define the behavior of certain language features, while prototypes are a language feature of JavaScript that are used to define the inheritance chain of objects. Define the behavior of certain language features. So I have two different questions. One I think is, maybe I should ask this here. And this one I already asked. So how are dunder methods different than normal functions? What exactly does it mean to create a class in Python? How is it different than the prototype? Inheritance, JavaScript. I think this one makes sense to ask first. I think I'll be right back. In Python, a class is a template for creating objects. It is a way of defining the structure and behavior of objects in a more organized and reusable way. Here's an example of a simple class in Python. In this example, person class is defined with the init under method and a say hello method. The init method is called when an object is created using the person class. And it is used to initialize objects, blah blah blah, to create an object. About this function. Class, blah blah blah. JavaScript prototypes are a way of defining the inheritance chain of objects. An object's prototype is an object that the object inherits properties and methods from. When you try to access a property or a method of an object, JavaScript will first look for the prototype or methods on the object itself. If it is not found, JavaScript will look for the property or method on the object's prototype. This process continues up the prototype chain until the property or method is found or the end of the prototype chain is reached. Here's an example of a simple constructor function in JavaScript that defines a property. This example, the person function is defined with a prototype property that has a say hello method. This method is then inherited by the person object when it is created using the new operator. When the say hello method is called when the person object logs a message to the console using the name property of the object. Overall, the main difference between classes in Python and prototypes in JavaScript is that classes are a way of organizing and creating objects in Python, while prototypes are a way of defining the inheritance chain of objects in JavaScript. I think this is a good thing to save for later, because I want to understand more what the implications of this difference is. It seems like the main difference is that in JavaScript is everything starts with the function and then the class is the chain of connections of the function. And then Python is more of a way to organize different objects. That's the main key difference. And that's why I think that JavaScript leads more towards composition and then Python towards object-oriented. Main difference between class in Python. Organizing and creating objects in Python. Prototypes are a way of defining the inheritance chain of objects in JavaScript. I think this question is not gonna give me anything good, so because I kinda understand now the difference, sort of, based on this other response here. It's helping me clarify more what's the difference. And I think if I ask a question like this, it's just gonna give me an answer that it already gave. So the difference is that the Dumbo underscore init creates a different, allows you to create a template for creating different objects with the same structure. But the new keyword allows you to have access to the prototype chain of a function. So it's like a class in JavaScript comes with the inheritance from the built-in class, which is the parent of all classes in JavaScript, which is the object class. So how is the object constructor created in JavaScript? What is that's roots of all in JavaScript? And after I ask this question, I think I'm gonna ask a question of what is the difference between using a normal function? Yeah, this question here. The normal functions. So I think I'm gonna scratch this one. I think I sort of answered this already in my mind, but I'm gonna ask this again probably. This one. Yeah, I'm gonna ask this one first and then this one. It's kind of hard to stay only on one thread and think about whether or not I should create two different chats so that the history is different on both, and then focus on classes on one and then their methods on the other. But JavaScript, the object constructor, is a built-in function that creates an object wrapper for a value. When called with the new operator, it creates an object with the given value as its prototype. The root of all prototypes chains in JavaScript is the object.prototype. All objects in JavaScript have the object.prototype in their prototype chain, so any properties or methods defined on object.prototype are available to all objects in the language. Built-in function that creates an object wrapper for a value. I think I'm gonna save this as well. I should save on the other file though. The other outline. Here the object prototype. Okay. What is the source code of the object? Interesting. Are there any differences Object isn't the There are a few differences between creating an object using object literals and using the object constructor. Syntax: object literals are use curly braces while the object constructor is the new operator. Performance: creating an object using object literals is generally faster than using the object constructor. Prototypal inheritance: when you create an object using object literals, the object has object prototype as its prototype. When you create an object using the object constructor, the object has a different object as its prototype, depending on the arguments passed to the constructor. Here, object of prototype is their prototype. On the other hand, here object 1 and object that are prototype as its prototype, while object 2 has a different object. Oh, I understand. So anything that you pass is gonna be the prototype of the initial object. And maybe, so I should do more questions about the under method. I think I understand well enough the prototype thing. I'm trying to think about how I'm gonna explain this in a way that it is simple and is gonna make people understand without being too confusing. And explaining this difference between the different designs of the language. Yeah, I think in order to understand that, I have to understand how the under methods work, because then, yeah, now I need to understand more the class initialization of Python, the implications of that. This answer clearly is wrong. Based on other stuff that is sad. Yeah, this is the problem with using ChatGPT. JavaScript, the __ methods. I wonder how ChatGPT 4 is gonna look like. I think they said it's gonna come out this year, but I don't really know. And they're using ChatGPT as a training, let's say. I forgot the word in English for GPT-4. But I assume it's gonna be a lot better than ChatGPT. And ChatGPT is already really good. JavaScript dumbo _ methods are special methods that have names with dumbo _ such as proto. These methods are used by the JavaScript engine to implement certain internal behavior, and they're not meant to be called directly by the user. Normal functions are functions that are defined by the user and can be called by the user as needed. Here's an example of a function. And here's an example of the under method. So it's interesting why it gave me this answer now and the other answer before. I guess that obviously has to do with the history of the conversation. But I'm thinking about in the language model how that works. I think the threads of the conversation are going to influence the pathways of the weights and biases of the model, which are going to leave you in a different space of the brain, let's say, because the brain is the brain of the machine learning model, I think, is just a bunch of weights and biases. And obviously it's more complicated than that with I don't know what algorithms they're using for training the model, the backpropagation thing, and the randomization and initialization of the weights and the memory, how they're making the memory work. I haven't studied recurrent networks a lot, so I don't really understand well how they work. But I assume this uses a recurrent neural network. I'm not really sure actually. But I think depending on the path, the initialization of the conversation is gonna create a different path in the network of weights and biases that makes it give a different response. Yeah, but I wonder if there's a correlation between the accuracy and that pathway. Another thing that I think about regularly is that lies are truths and truths are lies. So lies is analogous to potential and truths are analogous to matter. So everything is always relativistic because of that, and that's the flaw of the scientific paradigm. But there's not much that we can do or I can think of, because then through the limitation you go to philosophy, which is the overall branch that encapsulates science, I think. But the nature of science is you study everything based on events, and the events are connected through time, and that depends on the reference frame of identity that experience that space-time. So everything that is considered as a fact or truth is dependent on the frequency of awareness, of observation, of an observer, because everything is relative. So the illusion of past and future creates the cause and effect relationships, which creates the structure of the abstraction of observer in space-time. And that is dependent on the awareness of the observation, which is the frequency of computation that happens through the exposure of data in the environment. That creates the sensation of past and future, and then creates the cause and effect relationships, which creates the laws of physics and the scientific paradigm. So that is analogous to truth and lies, because it's the same thing. It's a probabilistic distribution. What is considered as a truth, is relative to the density of matter in space-time, and because it generates gravitational force. So what's more solid is considered to be more truth, because it's more reliable in space-time. So if an event happens all the time, it is more solid, even if it's abstract, because there's a higher degree of accuracy in the prediction of that event. But that doesn't mean necessarily that it's inherently true, because it can change at any time, and there's no way to predict, because all your predictions are dependent on your assumptions over the past and the cause and effect relationships that it has with the future. So those things are entangled with the observer. So that's the problem with science, is that it can always be wrong. Anything that you know can always be wrong, because it's dependent on the state of awareness that you have in the present moment, which creates the structure of space-time, which is this cause and effect relationships. And this means that there is no truth or lie, it's just different distributions of density in relationship to an observer, which creates the mass. And this is the fundamental problem with machine learning as well, I think, and these models, I think, is related to, is exactly the same, because there is the entanglement of the distribution of data, and algorithms are the same thing, in the same way that left and right are the same thing. It's just they are always relative to the observer, which creates this relativistic symmetry, which is a multifractal. So the language models and the weights and biases depend on the data they are trained on. So that's the question and the hard challenge of defining what is considered to be as accurate. Because I can ask, what is an accurate answer? So that depends on all these connections of cause and effect relationships that are dependent on each other, and they're always relativistic by nature. So the data creates the algorithm, and the algorithm creates the data, because they're the same thing. So the question is, how do you find what's the highest accuracy answer? That's going to depend on the density of the distribution of the data, I think, and the parameters of the algorithm that creates the decision or the information which is the distribution of lies and truths across the spectrum of the geometry of the weights and biases. It's kind of like playing poker. In poker, if you only think about the hand that you're playing, you're going to play really bad because you're not aware of the context that makes up the distribution of bet sizes that creates the whole game. So if you want to be able to play well, you have to think about the ranges. And the ranges are the context of the thing that is being, the game that is being played. So the hand in the present moment, you have to think about all the hands, all the moments. Then you have to create a strategy based on that. And that's the point of singularity or paradoxical point between the context and what's happening right now. And it's always subjective in a way because there's the volatility. So you can't really predict with 100% accuracy. You can't really solve the game because there's an infinite amount of potential of the things that can happen in the future and an infinite amount of bet sizes. But you can reduce the size of the game tree by creating a multi-factor structure, and that's pretty much what I assume that a multi-color simulation is. You're just reducing the space, the search space, in order to get closer to the multi-factor aspects of the game. That's analogous to a lot of physics. So the overall distribution of the Nash ability that you become unexploitable in poker is analogous to the laws of physics in science, where is fitting a multi-factor structure in space-time. That's why it's reliable, but doesn't mean that is true. So I think the same thing has to happen here, where you have some combination of these language models with something that tries to find the Nash equilibrium of truths and lies in order to fit the patterns of behavior. Not the patterns of behavior, the patterns of the structure of the distribution of lies and truths, which is the relationship of the current state of matter in relationship to the potential that exists in order to determine the evolution of information across the field, let's say, or across what's happening right now. Because the past and future are entangled through this self-fulfilling prophecy of the laws of science. I think I'm gonna stop now. I'm gonna have lunch, and then I'm probably I think I'm gonna stream more because I have to study more the other methods. But maybe I'll study this off stream. I'll watch the videos, and then my goal for today is to be able, hopefully, to do these 2 videos of the other methods and classes. And hopefully I can keep making 2 videos a day. I think that's a good pace, because these videos are hard to make, so yeah. So I'm not really sure, but if I'm not back today, I'm probably gonna be back. Well, also I have other stuff to do today, so maybe I'm not gonna be able to stream anymore. I think there's something from Build Space today at 1 p.m. that I think I'm gonna participate, and then there's some other stuff that I have to do. So if I don't come back today, I'm probably gonna come back tomorrow at yeah. So